recording so I don't forget. And we are going to start with a little review of what you did last night in terms of accuracy and precision. So you will want some sort of paper. It can be in your book. It can be a blank piece of paper from the back. It can be anything, okay? Because this is just a separate little review that we are doing to make sure that you understood the concepts. Hopefully everyone did the homework unless we misread it, whatever. But we're reviewing it anyway. Okay. So what you're going to do is you are going to define accuracy and precision. Try to explain the difference between those two terms to your neighbor. Okay? So have a little discussion with your neighbor and try and explain the difference between the two. Accuracy and precision.
Is that something right? Is that more than right?
Okay. Accuracy. What is accuracy? Anyone want to share their definition with us? How close a measurement is to the, and there's a reason that I double underlined the ac in accuracy, because it is how close it is to the actual value, okay? Now, this is one area where you do need to have a little bit more in the definition so you understand it completely. Normally, in chemistry, we will make more than one measurement, okay? Because we want to make sure that we are doing things several times so we can take a nice average and get better results that way. So, if you have a set of measurements, it is how close the average is to the actual value. And you'll notice I'm kind of lazy. If I have a choice to not write things twice, I will just point at it, okay? Oh, for a set of measurements, I'm sorry, that should have an S at the end. Precision. Give you a minute to write that down if you want to write it down. Precision, anyone want to give me a definition of precision? We could start again with how. Close. A set of measurements are to each other. Accuracy, how close to the actual value. Precision, how close the measurements are to each other. The reason I underlined the re is because it is how reproducible the measurements are. Can you reproduce the same data, or are you getting things that are wildly different? Okay. And Mahan, you had another word for that. What was the word that you used? Consistent. Okay. So I'm going to show you another way of writing without writing. If you put these little quote marks underneath, that means I'm saying the word how again. Okay. So that means how. How consistent the measurements are. Okay, that's what those little dittos mean. It just means whatever the word above it was, we're just copying it down below. That way you don't have to rewrite the whole sentence. Back before people posted things online, because there was no online and that sort of thing, taking actual physical notes was a very, very important part of studying. So I got good at writing things quickly. So I'll give you my little tricks. If you like writing things, apparently they've done studies that show that if people actually take their own written notes, even though they're not catching everything with those written notes, they actually like intake it more thoroughly and they understand it better. Don't get behind and like be like, oh no, I'm missing things. Just try and jot things down. Even if you don't get all of it, it will be okay, right? Because you also have your workbook and all these other things. Okay, so those are our accuracy and precision, and we are going to try to draw a few little pictures that represent certain degrees of accuracy and precision. We are going to draw a target. Okay, that is the center of the target is what we are aiming for. And we want 4 points or X's. So if you were throwing darts at this target, we want 4 points that are both accurate and precise. So show me both accurate and precise. So you have to think, if I want it to be precise, what do you need the points to be like? If I want it to be accurate, where do I need those points to go? Give that a try. Once you have tried it, you can show your neighbor and compare and see if you got the same thing. If it's different, you can argue with each other and be like, no, I'm right. No, I'm right. Okay? Or you can sit there and not draw it. I don't know. Participation always gets you more.
Is that L for you or
Hmm?
that L like this?
The L?
Yeah.
Oh, it's my son's L, but he's like not an L anymore, so I actually wanted to know if anyone needed an L.
Oh.
So if anyone needs an L, the sticker, because nobody in my family needs it anymore,
But,
and it's either that or I'm gonna throw it away.
okay.
Right?
If I say
You need an L, excellent. Good stuff. You try to get these out of
What
my
if we
house.
don't have the license?
Huh?
What if we don't have the license?
Well, here's the next one.
Oh yeah, see? Hmm?
Is that why people steal?
Yeah, because if you don't have the license, you can.
Oh,
you
do
can
you have a
drive.
license? Oh.
Exactly.
Oh. Okay, if you can show me your license, you can have the L. I don't know. Maybe I should just throw it away. It just seems wasteful to me, like just
It
garbage.
can be a memory.
Keep it till next year, and then I'll have my grade 12s, and then people will have their licenses and stuff. Yeah. Okay. Pardon me? Yeah. It's a good idea. All right. So we have 4 points. If they are precise, they should all be close together. So, and if it is accurate, where should they all be close to?
More near the center.
More near the center. Okay, so we've got maybe 1, 2, 3, 4. Okay, that is both accurate and precise. That one's pretty easy. Yes? We're going to do another fairly easy one. I want this one to be precise, but not accurate. So if we are precise but not accurate, the points have to be close together or far apart? They have to be close together. Where should they be? Should they be near the target or far away from the target? Far away from the target. So we could put them here. That would be possible, but they should be clustered together because they are precise. Or we could have it or down here, whatever, as long as it's not really near the target. Okay? So that is our precise but not accurate. Now I'm going to give you the hardest one. The hardest one. I want this one to be neither accurate nor precise. Neither accurate nor precise. Pardon me? We do have homework. I'm going to post it on Teams. We have the Google medical thing. I have to take somebody in the office. And so I can write it on the board. Oh, so it'll just be on Teams. Okay. Okay, so it's neither accurate nor precise. Now I'm going to let you know that this is tricky because most people want to do something like this. And if you did that, you've done what most people want to do. The only problem with that is it is definitely not precise, but if you want to take the average of these points, what you do is you draw a shape that connects them, and you say, where's the middle of that shape? About there? And I'm not very good at drawing, right? I could have drawn it better. But that is, so that particular one would be accurate, but not precise. Okay, so we don't want that. How could we do it so that it is actually neither accurate nor precise? We need them to be far apart, but we also need them to be sort of more to one side or the other, or more to the top or more to the bottom. Yes? So they need to be far apart.
There you go.
Okay, we could do that. That would work. And if we draw our little shape with these things, okay, where is the center of that? The center is about here-ish. Okay, it could be to the right or to the left, but it's definitely not at the bullseye. Okay, so you need the average, the center of the shape, to be not at the center. Okay, so if it's not accurate, we need the center of the shape to not be at the bullseye. Do you guys know the term bullseye? I feel like it's one of those terms that perhaps if English is your second language, you might be like, what is a bullseye? It is the center of the target. Okay? Okay? So that is our neither accurate nor precise. And now you can do the final one, which is going to be accurate but not precise. Thank you. I'm having trouble getting my brain to go today. That's a terrible circle. I'm going to try that again. So just like we did for what we shouldn't do last time, you could have them say here, 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 and here. And if you draw your shape, you get the center of that shape at the center of the bullseye, okay, of the target. Other ways you could do accurate but not precise. I'm not going to draw the whole target thing, but you could have like one here and one here and one here and one here. Yeah? You could have here and here and here and here. Okay? Don't get too creative. Here's the thing. Are we really going to spend a lot of time in chemistry throwing darts at targets? No. What we're really going to do is we're really going to take measurements. We're going to have actual numbers, and you'll be able to look at those numbers and say, are the numbers close together? Are they close to each other? Is the average of those numbers close to the actual value? So the targets are nice for a visualization, but like I said, you're not going to be spending lots of time throwing darts at targets or doing archery practice or anything like that. Okay, so don't worry too much about this, but this is the kind of question I could ask you on a quiz on accuracy and precision, which I think should take place on Friday. Now, I cannot remember what I talked about with this block about quizzes. Quizzes are re-quizzable. Okay, did I mention that last day, or was that just my other block? Does anyone remember that? No, okay, so I've not said it to this class, so it's a good thing I'm saying it now. If you don't do well on a quiz, you can re-quiz it. Some quizzes I have a second version. Some quizzes I have 3 versions or 4 versions. I think accuracy and precision, I only have 2 versions. So if you don't like your mark the first time, you can take it one more time. Okay? Quizzes are re-quizzable because I want you to really master the topics, the skills. Okay? When you write a test, however, tests, no retests. None. Never. Nada. Okay? Because you will have time to have practiced, done all the quizzes. Basically, when you study for your test, it will be like a whole bunch of the quizzes all in one place. Yes? So you will have actually practiced for the test ahead of time. Yes? The other thing is if you really bomb the test and you're like, I'm really unhappy with my 65% and I would like to bring that up somewhat, you can come in and do corrections with me. Okay? But it's not just, I get my test back, I copy my friend's paper, and I do my corrections, and I make things up, or whatever. No. What you do is you come in, and obviously it wasn't understood the first time, so we will go through it together. I will have a conversation with you about each question you did wrong. Maybe it's something where you just misunderstood the question, and I can find out, oh, you actually knew what you were talking about, you just didn't show me. Right? You just misunderstood the question. Or maybe you don't know it and I can teach it to you one-on-one and you get that extra support. Okay? There's going to be a maximum it can go up to because otherwise I'm just going to have everybody like, oh, well, I'm going to do my corrections, then I'm going to do better than the person who did in the first place. So I think usually I do corrections up to about 70%. Okay? So if you get over 70%, you're just there. Or maybe 73 because then you have a B. How's that sound? Okay, so you can do corrections up to 73%, and then that's it. If you get over 73%, you're just there. Okay? All right, so that's quizzes. Quiz on Friday on accuracy and precision. Your homework tonight will be to do a little extra practice on accuracy and precision. Okay, and then if you want extra practice, like say tomorrow, you're like, oh, I would like extra practice. I will sign you out a Hebden Chemistry 11, they have some accuracy and precision questions in there as well. Okay, so there's an extra textbook that you can sign out. Okay, it's small. We have enough that I have one class set in one of the cupboards at the back. So you can take this home and leave it at home. You don't have to carry it around with you, okay? And this is just a source of extra problems. So if you're like, I need more practice on X, Y, or Z, you will be able to find X, Y, or Z in here, and they have worked answers in the back. If you're like, I don't want the book at home, I'm going to lose the book, I don't want to pay for the book, it is also going to be up on Teams. I haven't posted it yet, but it will be up on Teams in the files, so you can just go to it there. I'll let you make that decision next day. We won't do it today. All right. Accuracy and precision it was. We're going to take a quick diversion to some units. 1.4a. And I need to now go to your actual block, 1.4a, which is on page 61. And we're going to focus in on this little table here. And you are going to tell me if these units look familiar. These units and quantities. Do most of them look familiar? Okay, most of them look familiar. The one that might look a little strange is maybe the amount of matter. Yeah? Like where's that? Where did that come from? Oh, we've got amount of matter and its symbol is N. Wow, that's weird because volume was V, distance was D. Those seem to make some kind of sense, right? But what the heck is N? Okay, so we're going to talk about that one just for a moment. This actually measures the amount of matter by counting the number of particles. So that's where the N comes from. It is the number of particles. And why don't we just count particles? 1 particle, 2 particles, 3 particles. Well, if I have a mole of particles, that is the unit for a mole, that means I have 6.02 times 10 to the 23 particles. And if you know exponents, if you know scientific notation, you know that this is a very big number. In fact, it is this number right here. Okay? Now, can you imagine a tablespoon? Okay, if you don't know what a tablespoon looks like, let me see if I have a spoon here. That's about a teaspoon. Okay? That's about a teaspoon. 3 of these would make a tablespoon. So you're looking at something that's like, you know, tablespoon is usually about that big around and it sort of dips down. It's kind of like a soup spoon. Okay? 1 tablespoon of water contains approximately 602 hexillion, which is what this number is, 602 hexillion water molecules. So do you see why we don't count them 1, 2, 3, 4? We would be here forever. So instead we count them 1 tablespoon, that's 1 mole. 2 tablespoons, that's 2 moles. Okay? Don't worry about moles too much. That's going to be unit 5. Okay, we spent a whole unit talking about that number. But just so you're getting the idea of it, that is one of the quantities. Sometimes students get confused between the quantity and the unit. Okay, so I'm going to give you an example of a sentence. The quantity, volume, V, is measured in liters, L. So if I have a graduated cylinder, it's a graduated cylinder, I will be measuring in milliliters, okay, which is another form of liters. You guys a second to write that down. I would always say my number here that I read here is 96. So this is 96 milliliters, not 96 volumes. Yes? If you can put a number in front of it and it sounds sensible, then it is a unit. 96 milliliters. Yes? Does 96 volumes sound okay? My volume is 96 volumes. Blah. Okay? If you say, okay, I've got a distance, which one is the unit? Is it distance or is it meters? Would I say it's 10 distances long or would I say it's 10 meters long? I would say 10 meters, and that tells me that the meter is the unit. The quantity we are measuring is distance. Does that make sense? Okay, so you will be responsible for knowing, yes, this is on page 61. page 61. You will be responsible for knowing the quantity symbol, the unit, and the unit abbreviation. It is important which ones are capitals and which ones are lowercase. So volume is a capital V, and liter is a capital L. So if you have milliliters, milli is a little m, liters is a capital L. And I'm going to be really picky about that. Okay, Chemistry 11 is a bit about being really, really picky so that when you get into higher level chemistry, it becomes really easy to read your work and consistent. You have a beautiful flow to things, and it's not difficult for anybody, professor, TA, whoever it is, to read your work and understand what you are saying. Okay, so you want to be consistent with what the standards are. All right, so capital V, capital L. Distance is a small d. I'm going to write small instead of lowercase because it's less letters. Small d. Meters is a small m. Remember, amount of matter, we are counting the number of particles. Okay, that's a small n. And they abbreviate, I don't know, they're so clever. They abbreviated mole by taking off one letter and making it mole, right? And we just got rid of that little e there. I don't know. It's a little silly, but there we are. Temperature. Now, you're probably much more used to having temperature being in degrees Celsius rather than in Kelvin, okay? And how you write degrees Celsius, I do want to, the degrees go first, and then the Celsius goes second. Do you guys know the symbol for degree? It's a little circle, okay, degrees Celsius. So degrees Celsius looks like that. Did you have a question?
Yeah. Talking about the distance, why is not like C?
Pardon me?
In the distance?
Yep.
C or centimeters.
Oh, we could have centimeters. Yeah, we could. We could have centimeters. Okay, meter is like the basic unit, and you can have any number of prefixes on that. And tomorrow we'll talk about prefixes. Okay, but for today, we're just sort of doing the basic unit. So we have liters, which could also be milliliters or kiloliters or centiliters or deciliters. Okay, so meters is the basic unit. We could have centimeters, kilometers, okay, all sorts of different meters. These are just the basic ones. Okay. Now, why on earth do we have this Kelvin thing rather than degrees Celsius? Because if we're in the chemistry lab and we've got ourselves what is this called? For measuring temperature, this is a thermometer. Okay, we have a thermometer for measuring temperature. If I look on here, it goes up to 100 degrees Celsius. So what is this business with Kelvin? Well, we are actually learning right now a standardized set of units that are used in all sciences, okay? This standardized set is called SI units, SI units. And it stands for the International System of Units. And if you're like, well, wouldn't that be IS? And yes, you would be correct. But for many, many years, French was the language of science. It was the official language of science. So it was système. Where is it? Système. There should be an E on that. International. And I apologize for my bad French accent, okay? But that's what it came from. That's why it's SI and not IS. It is the international standard for measurements. And what they did is they said they're going to have something to compare to. Okay, so a standard meter, let's go look up what it is. I think it's a certain number of wavelengths. The meter has been defined as the length of the path traveled by light in a vacuum during a time interval of 1/299,792,458 of a second. Huzzah. Okay, so they have all these little standards. You don't need to know them because they're crazy like this. 299 million some odd somethings of a second. That's crazy. Okay, but that is the definition of a meter. They have definitions for all of them. Okay, so a second is how many times a quartz crystal vibrates or something along those lines. They used to have one that was really nice and visual. Okay, it used to be that the mass was standardized with a kilogram, and they had a block of metal. I think it was iridium. It could have been something else, but they had a block of metal, and it was sitting there under glass, okay, in a vacuum, and they were like, that there is a kilogram, okay? And everything else had to be compared to that one block of metal. That was the official kilogram. Everything else was compared to it. And because they had that block of metal, that's why the official unit is a kilogram and not a gram. Okay? Why use a kilogram rather than a gram? Well, it turns out that block of metal, even though it's sitting there undisturbed, some of the atoms break down into smaller atoms and they give off particles. So over time, this thing was losing mass. So it started out as a kilogram, but over time it became less than a kilogram. Okay? So they came up with a new definition for a kilogram that's not based on this block of metal, but I don't understand it. Okay, I'm a chemistry teacher. I do not understand it. Feel free to read it on your own. Go to like Wikipedia, look up kilogram, and you'll find there's some explanation. It's like blah, blah. There's so many words. I don't understand. I still visualize a block of metal because that's something that my brain can comprehend. Okay, but all of these things in here have been compared to some standard, and that's why we are learning them here. Okay, so Kelvin, degrees Celsius. We will be using degrees Celsius, but you do need to know that the SI unit is the Kelvin. All right. Time is in seconds. Not that minutes are bad, but they've standardized the second, and then a minute is 60 of those. All right. And if you're thinking, there's going to be a quiz on this, because yeah, there is going to be a quiz on this at some point. How am I going to remember these? How might I possibly remember these? I'm not holding out hope for you guys. You're kind of quiet, but see if you can beat my last block, because I'm going to teach you a song to remember these. Okay? So I'm going to sing it for you a couple of times, and then when I say join, everyone join in, everyone is going to join in. Now, if you're terrified, if this terrifies you, you're like, I am not singing, mouth the words. Okay? So it's going to go liters, meters, moles, and Kelvin, kilograms, and seconds. Here's the tune. Liters, meters, moles, and Kelvin, kilograms, and seconds. 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 And if you're at home and you know everyone is out and you're not embarrassed, you can be like, okay, I'm going to do that, and I'm going to write down the symbols. Liter, liters, meters, moles, and Kelvin, kilograms and seconds. Liters, meters, you're coming in on the next round. Moles and Kelvin, kilograms and seconds. Everybody, liters, meters, moles, and Kelvin, kilograms and seconds. Liters, meters, moles, and Kelvin, kilograms and seconds. One more time. Liters, meters, moles, and Kelvin, kilograms and seconds. Liters, meters, moles, and Kelvin, kilograms and seconds. One more time. Liters, meters, moles, and Kelvin, kilograms and seconds. Liters, meters, moles, and Kelvin, kilograms and seconds. One to last time with clapping. Liters, moles, and Kelvin, kilograms and seconds. Liters, meters, moles, and Kelvin, kilograms and seconds. Thank you guys very much. You did actually a pretty good job, okay? So, at some point there will be a little quiz just on what are the SI units and what quantities do they measure. What that requires then is for you to say liters is measuring volume, which is V, and meters is measuring distance, which is little d, and moles is measuring amount of matter. Okay, Kelvin is measuring temperature. All right. Basically what you'll get is you'll get a little chart like this, but it will be blank and you need to fill it in. It does not need to be in any particular order. If you hate the song, if you're like, Miss Spence, that was a terrible song, I'm not singing it, I want to do it in my order, I want mass to come first, well, bless your heart, just do mass first. It's all good. Okay? Do whichever one, as long as you are consistent across the row. Okay? So you need all of this to be consistent. Yes? Okay, that's it for that. Moving right along, we're going to go to 1.4b, which is on page 65. Okay. Pretty soon we're going to start doing some labs. We will need to make measurements to do those labs, so we need to know how to record our measurements for a lab. And we need to record them with the correct precision. So we need to know, if I've got a ruler like this, how many decimal places do I go to? Okay, so that's going to be our job, is to figure out how many it is. So for any measurement that we make, the last digit is always considered to be the uncertain or estimated digit. So if we look at this pencil here, tell your partner what you think this measurement should be. Tell your partner what you think our measurement is. How many people like 6.1? How many people like 6.2? You're both right, okay? If you like 6.3, you're also correct, okay? And that is because our last digit is going to be estimated or uncertain, okay? So we are absolutely sure that it is 6 point something, yes? So we are not unsure about the 6. The 6 is certain, okay? So the length of the pencil is going to be 6.1. Do you guys think that's an awesome measurement? No, what's missing from that measurement? A unit. Anytime you write a number in chemistry, it should have a unit. There's an exception to that where we're doing a little bit on sig figs and we just are like, let's just work with the numbers and screw the units for a little while. Okay, but I will let you know when you can leave out units. All right, most of the time, if you have a number, it should have a unit. So our unit here, I didn't write it on here, I really should have. I need to fix that. Don't mind that little star and fix, that's for me to fix it for next year so that it says centimeter there. 6.1 centimeters. So every measurement that you make for a lab or for anything else should have 3 things in it. Number 1, you need to have what you are measuring. You're measuring the length of the pencil. So you're actually literally going to write down length of pencil. And then you're going to have an equal sign. And in your measurement, this 6 is certain. That means we are not guessing. We know it is a 6. And that is uncertain. Because we could have written 6.1 centimeters, or we could have written 6.2 centimeters, and that would have been fine, okay? That's because that last digit there is uncertain. You could write 6.3, that would also be fine. So every measurement, when you write your test for this unit, when you write your quiz for this little section, you are going to be given 3 marks, actually 4 marks, for every measurement. Have you written what you're measuring? Have you given me an accurate measurement? If you wrote 8.2, obviously I cannot say that is correct because that is not 8.2. So it has to be correct. So you get 1 for it being correct. You get 1 for having that single uncertain digit. You need to have 1 and only 1 estimated or uncertain digit. Okay? You have to have 1, but not more than 1. Okay? And you have to have your unit. So that's 4 marks. Okay? What you're measuring, correct measurement, correct number of digits, unit. Okay? So we need our estimated digit and we need the units. Now, let's just take a look at this pencil, or sorry, the ruler. Each line on this ruler is equal to how much? Each line is 1 centimeter, okay? We're going to talk very quickly about place values, all right? I think you all know what they are, but you might not know that word for it, okay? Place values, if I have 0, 0, 0.000, okay? This place value here, what position is that? That is the 1's position. If that's the 1's position, what's this one? That's the 10's position. Okay? Because what goes there before the decimal, 2 places before the decimal, is where your 10's are. So you could have 20.0. How many 10's do I have? I have 2 10's. Yeah? So that's our 10's position. This one here would be the hundreds position. Okay? Labeling these is not going to be particularly necessary, but I'm just going to use that language a bit, so it's good for you to understand it. Now, this one here, that is the tenths. Now, you don't have to write it as tenths. You can say it is the 0.1 position, which is easier. Yeah? It's the 0.1 position. This one is the 0.01 position. In other words, the hundredths. Okay, this one here, 0.001. That is the 1/1000ths. Now, what's the point of all this? The point of all this is if our ruler has markings for every 1 centimeter, that's in my ones position, I can estimate one more position to the right. Okay, so if I have ones as my lines, then I can estimate the point ones. Okay, if I had lines for every 0.1, I could estimate the 0.01. Okay, so I can always estimate one more than the marked lines. Okay. I'm sure I have this phrased better else somewhere else right on this paper. So I'm not sure that we need to write that there, but we're going to anyway. So if this is 1 centimeter, we would estimate the 0.1. And don't worry, if it's not making sense, we've got lots of examples to help bring it home for you, okay? If the measured object is exactly on the line, so what do I mean by exactly on the line? Do you see that pencil tip there? It's basically touching the line. Yes, it's touching the 6. Would it be okay if I was to say my measurement is 6 centimeters? Would that be okay?
No, 6.
I have to have 6.0 because remember, I have to have an estimated digit. Is the 6 estimated? Am I wondering, is it a 6? Could it be a 7? Anyone wondering that? Could it be 7? No, you're like, no, it's obviously a 6. It has to be a 6. We're not unsure about that. This digit here is certain. But we need to have one estimated, one uncertain digit. And so that's why we are always going to add a 0. Okay? So if it is exactly on the line, you need to add a 0. And I'm going to put in brackets or 2 or 3. Because sometimes it will be or 2 or 3. Okay? We'll come to those later. What do you guys think about my measurement right now? How does it look? It's missing a unit, so we need to have centimeters. Is it missing anything else? Yeah, you need to put the equals and what you are measuring. I'm just going to show you how to shorten it so you don't have to write length of pencil every time, okay? Length can be abbreviated as the letter L, okay? I have a tendency to write my L's like that. That is a cursive L. Anyone learn cursive? 1 or 2 of you. Okay. Anyway, I tend to write them like that because then it looks different from a 1 and an L and an I. So when I write my ones, very often I'll do my ones like that, I'll do my L's like this, and I'll do my I's like that. Okay? So that they look distinct. You don't have to do that. All right? I can figure out what you mean from context. But to help you out, I will try to do them that way. So that's the little lowercase l. So we can say, we can shorten this. We can say L. And then we're going to put down at the bottom, we're going to write in small letters, pencil. Okay. This right here, this is a subscript. Did we talk about subscripts yesterday? Yeah. Sub means below. Script means writing. So if you write the little word pencil, it means length of pencil, but you don't have to write as much, which is nice. Okay, shorter is good. And I wouldn't just write L pencil, 6 centimeters. I would have to write L pencil equals. Don't use like a colon, write equals. It's just more standard, okay? Not a colon. No. Goofy pencil, goofy pen, making weird lines. Anyway, I'm just gonna get rid of that. All right, here we have a weird ruler. It only has 2 markings on it. It's got a mark at 0 and it has a mark at 10. Okay, that's it, right? So we got each line on this ruler is worth 10 centimeters, yes? So if each line is worth the tens position, then we can estimate the which position? Yeah, we can estimate the ones. So what do you guys think for this? 6? Sure. Maybe 6 centimeters? Maybe 7? Sure. Could we say 6.5? Could we say 7.5? Here's a question. How many uncertain digits are you allowed? You are allowed 1, but only 1. So if you are guessing at the 6 or the 7, you already have your 1 uncertain digit. You cannot guess at a second one. Okay? So just 1. So the answer, 6.5. No, because the 6 is already estimated. Only 1 estimated digit allowed. Okay, so no, we can't do 6.5, we can't do 7.5, it has to be 6 or 7. You could even say 8. I might say you're crazy, that's not 8, but you would be technically correct, okay? I might be like, no, that's a little bit too far off. You might lose that mark for having, made a good guess as to what the measurement is. All right, but you would be correct in terms of the number of digits you've recorded. All right, let's take a quick look at the next page here. Always estimate to 1 more digit than the smallest marking. How much is our smallest marking here? This is on our next page. What? Oh, I missed one? What did I miss? Oh, because each line on this ruler is worth 10 centimeters, we can estimate to the ones place. Thank you. Yes. Yes, take the flash. You put him on your arm. That way he's far away from everything.
Yeah.
Okay, there we go. Back in a flash. Sorry. Did I tell you the other joke the other day about the flash? Oh, because okay, so the flash is like our hallway pass, right? So, but you have to remember, he helps you to remember you have to be back in a flash. But if you go to the bathroom, You have to be back in a flush. Okay, sorry. Those of you who are laughing, A+ is for you. Yes. See, now I get it. Oh, so good, so good. Okay. All right. Moving right along here. What do you guys think? Could you please record what you think for this measurement? I got a 6.8. Anyone got another one for me? 6.7, sure. Okay, you might even go 6.6, but I think those two are pretty reasonable. Could we say 6.75? No, because we are already, those two there are our uncertain digits. We can only have one. So could we say 6.75? The answer is no. So that's one way you can figure out you can go to the point ones. The other way is to say, what is my distance here between line and line? My distance is 1 centimeter, so I can estimate. Do you guys know this dot, dot, dot? 3 dots? Okay, let me tell you what that is. Dot, dot, dot means therefore. Okay, dot, dot, dot means therefore. I use it a lot. If I ever write an abbreviation and you don't know what it is, like if I write BW and you're like, what the heck? That means between, and I'll just let you know, okay? So if I've written something and forgotten that I haven't taught it to you yet, just be like, hey, what is that? All right? Okay, so we have only one uncertain digit allowed. Each line on this ruler is worth 1 centimeter, and therefore we can estimate to the 0.1. Why did I write it up there? Because we're going to write it down here as well. 0.1's place. Now we have another ruler. This one's, we're getting better and better. Thank you. Better and better here. Okay, we've got this ruler and we've even blown it up big for you to see. Okay, so we are now at, let's see, this is 6, this is 7. So this one must be 6.5. Yes? Oh, no, okay, you're stretching. Okay, it's all good. This one here would be, we would have 6.6. We would have 6.7. So this one here is 6.7. And this one is 6.8. So we are somewhere between 6.7 and 6.8. Yes? What is the distance between two of these lines?
If you know for sure that it has 6.7, doesn't that make the 7 is 7.5 like after the dot? Doesn't that make a certain number?
This 6.7.
You didn't guess it. You know it.
No, we haven't measured it yet. We haven't done our measurement yet. We're just figuring out what each thing is worth. Okay? So what we've got here, it's somewhere between 6.7 and 6.8. So somebody give me a value. What could it be?
Oh, and it says 6.75.
6.75, sure, let's do that, okay? 6.75. Somewhere in between. What else could it be? 6.76? Sure. Okay, you might even say 6.77 or 6.78. I figure I think if you went to 6.79, maybe we're not quite close enough, but you could still maybe get away with it. it looks like it's at least halfway, so I wouldn't go below 6.5 because then you're sort of getting into I haven't estimated my numbers very well. I've done a bad job at estimating. Okay. So could you say that this is 6.755?
No.
No, because we have our uncertain digit here. Yes? So each line on this ruler is worth 0.1, and so we estimate to the 0.01. Okay? And what I'm going to get you guys to do for homework is a little bit of review for your accuracy and precision quiz, which is taking place on Friday. And so you are going to do 1.2b for homework. Okay. That will be some review for accuracy and precision for Friday. You notice we're doing spaced repetition here. You're doing a little bit today, and there's an accuracy and precision extra practice, which you can do either today or tomorrow or the next day. Okay?
Oh, I'm sorry. Let's see.
Yes.
I can write it down. I would always like to do it. Let's not my breath and then we go. Sound like
And that's okay. Thank you.
Not quite so much. See, I've actually like a lot of that.
I didn't have a choice. No, I wouldn't have had anything. I was the victim. I didn't do anything. I was just sitting there and then John crawled under the desk to get me. Yes. Oh no, it was 1.3 and 1. I'm gonna post up on Teams as well. Here, let's get this. Hi. It's so oh, this did oh, yes, we did. So you have we have one digit, and we have one.
See you tomorrow.
See you tomorrow. Have a wonderful evening.
Thank you, Miss.
Bye.
Miss Max, I'll put the pencil over here. Pardon me? Oh, thank you so much. Thank you so much.
Yes. Okay. So that's fine. Thank you for letting me know. I will record the lesson. We are probably going to be doing, I'm guessing, we'll probably be going back to elements, compounds, and mixtures a little bit. Okay. And we'll also be looking at the prefixes in the SI units. Just watch the video. You'll be good. Okay.
Thank you.
Yeah.